Good morning everyone, my name is Nitin and today we are going to study the second part of the trigonometric function chapter. In this chapter we have already studied about angles and its types and how to convert radian into degrees and degrees into radian. Today we are going to study the application part of it. Firstly, we just need to know the formula that we are going to use in this chapter. In class 10th, we have studied one chapter that is area related to circle. In that chapter, we have studied how to calculate the arc length. If we have given a arc in the circle and the radius is given, the angle theta is given, then we are going to find the value L, that is arc length of that circle. Since at that time we got to know the formula L is equal to theta upon 360 degree multiplied by 2 pi r. 2 pi r because it is circumference of circle. Theta is angle, that is this angle, and L is the arc length. Now if we put the value of 2 pi, since we know that pi is equal to 180 degree, r, this and this got cut. So we got to know that L is equal to theta r. And in this chapter we are going to study this formula and its applications. Now here L is arc length, theta is the angle suspended by the arc, and r is a radius of circle. Since we are going to use this formula, please take the screenshot of it. Now we are going to solve one question based on it and some others application based question also. So here the question is given, that is a wheel makes 360 revolution in 1 minute. So we have to find how much radian it takes in 1 second. Here, since we know that in 1 minute number of revolution is equal to 360. In 1 minute there are 60 seconds. So in 60 seconds number of revolutions are 360. In 1 second the number of revolution will be 360 divided by 60, that is equal to 6 revolution. Also we know that in 1 revolution, that is whenever a wheel moves full 1 revolution, it is 360 degree. If we want to convert 360 degree into radians, multiplied by pi by 180, 181 ja 182 ja, so answer will be 2 pi. So in 1 revolution angle will be is equal to 2 pi. So in how much revolution? 6 revolution. Angle will be 2 pi into 6, that is equal to 12 pi. That is the answer of it. If you have any doubt, you can ask me anytime. Please take the screenshot if needed. Now let us move towards the second question of that application part. Here we need to find the degree measure of the angle suspended at center of a circle of radius 100 cm and arc length of 22 cm. Here radius given to us is 100 centimeter and arc length, that is L, given to us is 22 centimeter. According to the formula, that is L is equal to theta r. The value of L is 22. The value of theta we don't know, and the value of r is 100. So this 100 will be get divided to the second size. So the theta will be 1150. Theta is equal to 11 by 50 radians. If we want to convert this radian into degrees, so what we have to do, that is theta is equal to 11 by 50 radians multiplied by pi upon 180 degree, 180 degree upon pi. 0, 0 cut. 18, 11 is 198 divided by 5 pi. 198 divided by 5 multiplied by 22 by 7. 198 divided by 5 into 22 into 7. 22 1s are 22 9s are 198, and after solving this we will get 9 7s are 63 divided by 5 degrees. After solving this we will get solving this further, we will get 63 by 5 degree. Convert it into a mixed fraction. So then we will get 12 by 3 5 degrees. If we want to convert it into minutes and second form, what we are going to do, 12 degree 3 by 5 multiply by 60. 5 1 ja 5, 12 ja 12 degree and 36 minutes is the answer. Any doubts? Now let us move to the third question. Here, in a circle a circle is given to us whose diameter is 40 centimeter. If the diameter is equal to 40 centimeter, then the radius will be diameter divided by 2. That is 40 divided by 2 is equal to 20 centimeter. Also, the chord length is given, that is 20 centimeter. What is chord? A chord is a line which joins any 2 points of the boundary of the circle. So, if we connect the center of the circle to the ends of the chord, the radius is 20, this is 20 and this is 20. Thus, it forms a equilateral triangle. It means, and the angle theta of equilateral triangle is equal to 60 degree. Since it's 60 degree, so let us move forward. Since radius and chords after joining makes a equilateral triangle in the circle, thus the theta will be 60 degree. Any doubts? Now we have to convert this 60 degree into radians. So 60 degree multiply by pi upon 180 degree. 61 ja 63 ja is equal to pi upon 3 radians. Now according to the formula, L is equal to theta r. L, the value of L is already given to us. The value of L we are going to find because L is equal to arc length. theta is given to us, that is equal to we have converted the 60 degree into pi upon 3 radians, so it will be pi upon 3, and the value of r is given to us, that is equal to 20. After substituting the value of pi, that is 22 upon 7, the answer will be 440 upon 21 centimeter. Any doubts? Now moving on to the next question. So the next question is, if two circles arcs of same length subtend angles of 60 degree and 75 degree at the center, find the ratio of the radii of circles. So the answer of this question will be, what they are trying to say is, we have two circles. The first circles, the arc length of both the circle is same. It means if its arc length is L, then its arc length is also L. The angle suspended by this is 60 degree. The angle suspended by this arc is 75 degree. So we are going to find the radius of this circle and these circles, and also try to get the ratio of R1 is to R2. Firstly, we know that in circle 1, L is equal to theta R. L is L, theta is 60 degree, and R is R1. In second circle, L is equal to theta R. L is L, theta is 75 degree, and R is R2. Take it is at 1 and this is 2. From first and second, we get 60 degree multiplied by R1. Since both this L are equal, therefore 60 degree into R1 is equal to 75 degree into R2. Since here R2 is multiplying, here it will divide, and 60 here is multiplying, so going to the second side it will get divided. 15 4 ja, 15 5 ja, 5 by 4. So the ratio will be 5 by 4. Any doubts? Moving on to the next question. Now moving towards the last question of the application part is, we are given a pendulum. This is thread of a pendulum and it is known as bob of a pendulum. When it moves, it forms an imaginary circle. Its left side limit will be this and right side reachable limit will be this. This whole thing is known as arc length, that is L. The thread is radius of the circle and it subtends an angle examiner or the question is like that. In this, a radius is given as 75 centimeter. L is given in 3 parts, in first case, second case and third case. In first case it is 10 centimeter, in second case it is 15 centimeter and in third case it is 21 centimeter. We are going to solve all these parts and we have to find the theta in every case. So the first part will be, since we know the formula, L is equal to theta R. What is the value of L in first case? 10. What is value of theta? We are going to find out. What is the value of R? 75. Dividing 75 on other side. 5 2 ja, 5 15 ja. So the theta will be 2 upon 15 radians. Moving on to the second part. Here L is equal to theta R. L is given as 15 and theta we don't know, but R is given as 75. So the theta will be 15 upon 75. 15 1 ja, 15 5 ja. So the theta will be 1 upon 5 radians. Moving toward the third part. Here L is equal to theta R. L is given as 21. Theta we don't know, since we have to find theta. R is given as 75. Theta remains the same and 75 goes to the other side. 3 7 ja, 3 25 ja. So the theta will be 7 upon 25 radians. If you have any doubt, you can ask me in the comment section. Now we are going to give you extra question based on it so that you can practice the topic more. So the first question will be, if a clock hand moves 30 minutes, whose length is 10 centimeter, find the arc length of it. The second question will be, if a wheel revolve 360 revolution in 2 minutes, find the angle subtended by it in 1 second in both degree as well as in radians. Third will be, if a pendulum of length 20 centimeter moves first part, second part, third part 120 degree, 360 degree will be in 90 degree and 60 degree, find the arc length of it. Take the screenshot of the question, please. The fourth question will be, if a if a circle is of radius 40 centimeter having a chord length of 40 centimeter as well, find its arc length. Fifth, if a circle of diameter 60 centimeter subtends the arc of 120 centimeter, find its angle in both degrees as well as in radians. That is your homework to solve all these 5 questions, and you have to give me the particular answer of it in comment section. If you have any doubts, you can ask it in a comment as well as. Please like, share and subscribe. Thank you for your time.